Welcome back to the deep dive. Today we're diving headfirst into something pretty intricate. It's all about how decentralized tech can, actually work for real-world businesses, especially with sensitive private data. We're unpacking NetX Private Data Services. It's a really innovative way to handle secure and flexible data access. If you've ever wondered how your company could use blockchain for private data, but keep that ironclad control and get great performance, well, this deep dive should shed some light.
Indeed. And our goal today really is to break down how this NetX infrastructure offers such a versatile framework. It basically empowers data owners to securely share data with service providers, even across, totally different blockchain environments. The aim is to forge this dynamic, sort of self-tuning data ecosystem where verifiable trust is absolutely paramount.
Okay, that sounds incredibly powerful. Also, complex. Where do we even begin to unpack the nuts and bolts here? What's the first piece we need to get?
Right. So at its heart, NetX, it's built on an architecture designed for both broad interoperability and really granular controlled access. Let's start with the main players. First up, you have the data owners. Think of Company A as our example here. These are the entities holding the data. They manage it using a special digital rulebook. They call it a data process contract. And that usually sits on their own private NetX Smart Chain.
Okay, so a private chain for the owner.
Exactly. And within Company A's own data center, you've got these crucial and tunnel services too. Liviatom, which is the off-chain computing service. It handles the heavy lifting, maybe complex analytics that are too slow or costly for the chain itself. And then there's Behemothum, the data process service, managing the actual data transformations. Think of them as Company A's trusted internal workhorses, processing data before it even hits that blockchain contract.
Got it. Company A has its data, its rules, its internal processors. So who's looking to access that data?
That brings us to the service providers, represented by companies B, C, and D in our scenarios. These are the folks who need access to Company A's data for their own apps, their own operations. And to make that connection happen, there's a really critical piece, the data access contract.
The data access contract, okay.
Yeah, think of it like the service provider's custom passport and translator, all rolled into one. It's a smart contract specifically designed so their applications can securely talk to Company A's data process contract. It enables that crucial sort of trustless handshake.
I see. So two different contracts. One for the owner's rules, the other is the provider's secure entry point.
Yeah.
And these live on NetX Smart Chains. Can you elaborate a bit on the public versus private versions? What's the difference there?
Absolutely.
Yeah.
And the NetX infrastructure is incredibly flexible here. You've got public NetX Smart Chains. These are great for broad interoperability, transparency, allows for wider scrutiny, shared access, that kind of thing. Then you have private NetX Smart Chains. These are really designed for enhanced performance, and they offer much greater control and privacy for the data owner.
Okay. Public for openness, private for speed and control.
Pretty much.
Yep.
And underpinning all of this is a really fundamental layer known as Trias Layer 1. Now, this isn't just about connecting blockchains. It's kind of like embedding a universal truth serum into every single data interaction. This layer manages what's called trustworthiness metadata. It handles routing services, performs vital security checks, and it operates across both public and private networks, ensuring this consistent, verifiable level of trust. It's what lets you confidently interact even with unknown entities in a decentralized world.
That's a huge claim, connecting trust across different chains, public and private. But trust is usually so subjective, right? How does Trias Layer 1 actually quantify and verify this trustworthiness metadata in a way that's decentralized and, tamper-proof?
Yeah, that's precisely the clever part, this trustworthiness metadata. It's like having a universal health report and a reputation score for every service, every piece of data in the ecosystem. It tells you in a verifiable way if a data source is legit, if a provider is reliable, if the data is clean. Trias Layer 1 does this by constantly verifying the integrity and the execution of processes. It gives you this verifiable, objective assessment of trust. And finally, linking all these different environments together are the cross-chain bridges.
Right. The bridges.
These aren't just simple data pipes between Layer 1 ledgers. They also crucially connect those Trias Layer 1 nodes. And that dual connection is absolutely fundamental for exchanging that trustworthiness metadata we just talked about. It's what makes the whole NetX ecosystem robust, especially for these hybrid setups.
Okay, understanding those building blocks is one thing, but seeing how companies actually use them, how they deploy and connect, that's where the real ingenuity seems to be. It's clearly not a one-size-fits-all approach. That flexibility is key. So let's look at the choices. Where can a service provider actually put their data access contract? The sources lay out three pretty distinct approaches.
Precisely. And for a service provider, yeah, the choice really impacts their transparency, their performance, and the level of control they have within the NetX system.
Let's start with scenario B. This is where a service provider like Company B goes for a public chain deployment, prioritizing transparency and secure billing. How does that work?
Okay, so in this setup, Company B runs its own Trias layer A1 node inside its own data center. That node connects up with the public Trias layer O1. Why? To get routing info, but also check out the trustworthiness, the properties of Company A's services. Only after that initial check, that verification, does Company B deploy its data access contract right onto the public NetX Smart Chain.
Okay, so why the public chain specifically for Company B? What are the compelling advantages there?
Well, this approach isn't just about swapping data. It's really about putting a fully transparent, auditable business relationship right onto the blockchain. The link between Company B's public data access contract and Company A's private data process contract. That's enforced by a cross-chain bridge. And a key benefit, as you mentioned, is automated, secure billing. Access consumes pre-stored gas fees that Company B already put into Company A's contract. Imagine like automatic trustless payments. Every time data is accessed, it's paid for with these pre-approved digital tokens from a shared pool. It's visible, it streamlines things, kills billing disputes. That's a massive headache solved right there.
Right, that automated billing is a big deal. So Company B clearly values that transparency and the automated financial side. But what if a company's main driver isn't transparency, but just pure raw performance? That sounds like Company C's strategy in scenario C. A totally different approach, deploying directly onto the data owner's private chain. How does that work?
Yeah, Company C takes a completely different path. After the initial handshakes, the setup protocols, it deploys its data access contract directly onto Company A's private smart chain. So what that means is both contracts to data access 1 and Company A's data process 1, they live in the exact same private environment.
Okay, that definitely sounds faster. You cut out the cross-chain hops. But security-wise, isn't that risky? Letting an external company's contract run on your private infrastructure, how does NetX stop that from being a huge vulnerability for Company A?
That's a very valid concern, and it's critical. You're right, the direct interaction on one chain dramatically boosts performance, cuts latency, but maintaining trust and security is absolutely paramount. So to mitigate that risk, Company C's own Trias Layer Wave 1 node has to perform extra rigorous checks and validations. It has to validate its own contract and the interactions it starts within Company A's private space. This ongoing verification is essential to ensure the integrity of that shared private chain isn't compromised.
Makes sense. Extra checks needed for that extra performance. Okay, so what about companies wanting the absolute highest level of control? A dedicated environment. That brings us to scenario D, with a company like Company D using its own private chain.
Exactly. Company D represents that peak of control and customization. It deploys its data access contract on its very own private NetX Smart Chain. This sets up a dedicated, fully controlled environment just for its data access needs. It allows maximum integration with whatever existing systems or bespoke workflows they already have.
Okay, but now you have two private chains, Company D's and Company A's. How do they talk to each other securely and reliably? Sounds like two separate islands.
They're not isolated, no. To make this work, a dedicated cross-chain bridge is set up specifically between Company D's private NetX Smart Chain and Company A's private NetX Smart Chain. But here's the unique part. This setup requires mutual verification on both sides of those private chains. So both companies are actively, continuously verifying the security and integrity of the data and processes flowing across that dedicated bridge. It creates this highly secure, very customized channel between them. Interesting. So these different models all hinge on these robust connections. What's really fascinating, though, is how NetX manages the connection itself, and especially that trustworthiness layer across all these different, sometimes clashing environments. That's exactly where the flexibility of those cross-chain bridges, powered by Trias Layer 1, really becomes indispensable. Like we said, they don't just move data between Layer 1s. They directly link the Trias Layer 1 nodes too, and that dual connection. It's fundamental for dynamically exchanging that trustworthiness metadata we talked about earlier.
Yeah.
It lets data centers actively search for data or application services that have the attributes they want, maybe a certain reputation score, all via Layer 1. This ensures trust and security are consistently upheld across the network, whether you're going public to private or purely private to private.
So putting it all together, these individual scenarios, B, C, D, they're not just isolated examples, are they? They seem like parts of a bigger picture. What happens when you bring it all together? What does NetX enable then? This general configuration you mentioned, building a small data network.
Exactly. This leads us to the general configuration, which really represents forming this vibrant small data network. In this kind of mature ecosystem, you have companies with their internal NetX infrastructure seamlessly connecting to the public NetX Smart Chain using those cross-chain bridges. And those bridges are vital, remember, linking not just layer 1s, but also the Trias layer 1 nodes. That enables the constant flow of trustworthiness metadata across the whole network.
And what's different about the roles companies play in this network?
This is crucial. In this setup, data centers like our company A example, maybe another one, company A prime, they can act simultaneously as both data owners and service providers. This dual role, it completely transforms things. Instead of just linear one-way interactions, you get this truly dynamic, multi-directional network. Entities can switch hats based on their needs, sometimes offering data, sometimes consuming it.
Wow, okay, so it's very fluid. But with all that flexibility in these shifting roles, how do companies actually find what they need and connect securely? It sounds like it could get complicated fast.
It is complex, but it's managed quite elegantly. Companies use Trias Layer 1 to discover and search. They look for specific data or services with the properties they need, including those vital trust attributes. Once they find what they're looking for, they set up connections by deploying data access contracts flexibly. They choose private chains or the public chain based on what they need right then: performance, control, transparency. And this whole integrated approach, the hybrid connections, the dual roles, the flexible contracts that forms the foundation of this small data network. It's an adaptable model for efficient, trusted, secure data exchange within the NetX world.
Okay, so let's pull all these threads together. For you listening, navigating these decentralized infrastructures, what are the key strategic takeaways from NetX? What should you be thinking about if you're looking to use or build on this kind of architecture?
Well, NetX's design really lays out a clear spectrum of strategic choices. It lets organizations carefully balance the key trade-offs. For instance, if transparency and broad interoperability are your main goals, then deploying on the public chain with that automated billing, like Company B did, that's a very solid path. It gives you clear, auditable records, predictable costs.
Right, and if performance is king, or maybe maximum control.
Well, for maximum performance, integrating directly onto the data owner's private chain, like Company C, that's optimal. But you have to accept those additional security verification requirements from the provider's Layer 1 node. It's a trade-off: speed for extra diligence. And then for ultimate control, customization, and making it fit seamlessly with your existing systems. Deploying on your own private chain with those dedicated private-to-private bridges, like Company D showed, that really stands out. It lets you build a totally bespoke environment.
So the choice really boils down to a company's specific priorities, maybe their risk tolerance too. But what about the bedrock? The security, the trust, the integrity of it all?
The consistent element, the foundation across all these scenarios, is that framework provided by Trias Layer 1 and the cross-chain bridges. These components are absolutely critical for establishing and maintaining that verifiable trustworthiness and solid security, even across very different hybrid blockchain setups. This infrastructure really tackles that core challenge, creating secure, multi-chain interoperability for private data. It moves us beyond thinking of blockchains as isolated silos. Now, it is important to note, from a critical standpoint, the available information doesn't explicitly detail the specific consensus mechanisms powering these NetX Smart Chains, nor does it give a full picture of the broader tokenomics or detailed governance models beyond that gas fee mechanism for Company B. Those are deeper questions you'd want answers to for long-term strategy.
Okay, let's try to quickly summarize then. What are the absolute essential insights from this deep dive into NetX Private Data Services that you should take away?
Okay, in a nutshell, NetX Private Data Services offer a genuinely multifaceted and flexible infrastructure for secure, controlled private data access. That's the headline. It empowers data owners to give access to service providers using various deployment models for those data access contracts. On the public chain, directly on the owner's private chain, or even on the provider's own private chain. The whole system leans heavily on Trias Layer 1 for verifying and maintaining trust, and on cross-chain bridges for secure, interoperable links between all these diverse environments. And ultimately, all these capabilities come together to form that small data network. It enables efficient, secure data exchange where entities can dynamically be both owners and providers, and it integrates with existing enterprise systems. It's really a robust pathway for organizations wanting to harness decentralized computing for their private data, tailored exactly how they need it.
And that wraps up our deep dive into NetX Private Data Services. It's pretty clear the future of decentralized data for businesses is all about, well, intelligent flexibility coupled with robust, verifiable trust, allowing companies to pick the best, most secure path for their specific needs.
Yeah, it really makes you think, doesn't it? How might these incredibly adaptable multi-chain architectures evolve even further? Could they enable even more complex, more dynamic data sharing across industries, maybe even across different regulatory zones, all while continuously strengthening those mechanisms for verifiable trust and security in our increasingly data-driven world?
That is a really thought-provoking question to leave things on. Thank you for joining us on this deep dive. Until next time, keep exploring.